Another type of equation you'll come up against is something like this, where we've got a trig function on one side of the equals and a trig function on the other side. As well as that, we have this squared thing again, which we solve slightly differently to the last one. So if we've got a trig function on both sides, what we need to do, we need to divide one of those by one of the trig functions. Now, we know that sine divided by cos gives us tan. Cos divided by sine gives us 1 over 10, which will still work, but we don't really work with that in maths methods. That's more of a specialist maths kind of thing. So what we're going to do, we're going to divide both sides by cos of x. And before I forget, I've got my 3 triangles of root 3, 1, 2, 1, 1, root 2, 1, root 3, and 2. So this is pi over 6, pi over 4, pi over 3, and I've also got my 2 unit circles, 1 per question. So now, from here, this sine divided by cos becomes tan of x, and because we've got a 1 here, and don't have anything in front of it, we're left with root 3. Cos x divided by cos x, remember, law of the universe, anything divided by itself is 1. Except for 0 divided by 0, that always bugs me. Anyhow, we want to simplify the left-hand side as much as possible, so now we've got tan of x equals 1 over root 3. So, tan is opposite over adjacent, so we look at our 3 triangles where the opposite and adjacent sides are 1 and root 3 respectively, and we'll see it's pi on 6. So this implies that x equals pi over 6. Now one thing I forgot to write was that we are solving these between 0, x, 2 pi. That's generally what you're solving it across, and you'll generally have 2 solutions for all of them. Sometimes 3 depending on boundaries, but you generally have 2, and you find that out using the triangles. So if it's positive, we've got our base angle of pi on 6, that's what we're going to use. So we're going to say pi on 6 goes over here, so we've got root 3 and 1, and then tan is also positive in the third quadrant, so we're going to have to turn this upside down, and we're going to draw pi on 6 out here. So if this little bit here is pi on 6, then to be in this quadrant, we are at pi plus pi on 6. So this ends up being pi plus pi on 6, which then tells us we've got pi on 6 and 7 pi over 6. So that's our 2 solutions that we're dealing with there. On to the next one. If we've got something like this, well, we want to simplify as much as possible. Now, what's really convenient is the fact that we've got a factor here, we've got a term here, cos squared x, and we've got cos of x. Now remember, this is the same as writing cos x squared. So we've got plus cos x minus 2 equals 0. Now, what does this look like? We've got something squared plus the same thing minus 2 equals 0. Well, I hope you're all saying it looks like a quadratic. So what we do is we say, let a equal cos of x. Hopefully it'll look more like a quadratic now. So we'll have a squared plus a minus 2 equals 0. Now, to solve for a, we've got to factorise this. 2 numbers that add to make 1, but multiply to make negative 2 are a minus 1, a plus 2, and that still equals 0. Now, we apply the null factor law. So we're going to say we'll start with this one for convenience sake, a plus 2 equals 0. So that implies that a equals negative 2, but we know that a equals cos of x. So cos of x equals negative 2. So we've got to ask ourselves, do we ever have a horizontal distance of 2? No, never. So this is not a solution. So we have to look at our other one. So we look at a minus 1. So we will have a minus 1 equals 0, in which case we're left with a equals 1. So now we're dealing with cos. Now we substitute cos back in. Cos of x equals 1. So whereabouts does cos of x equal 1? Well, it's here at 0. And where else in this domain will it equal 1? It'll equal, will it equal 1? It's going to also equal 1 at 2 pi. So it only happens at those two places.